not a big deal. Okay, so let's get started, if you don't mind. Pat, do you want me to start, or do you want to start? I'll go ahead and start. So this is welcome to, it's been broadcasting, so we'll have some extra at the beginning, but we're broadcasting now. This is the Node.js tracing and perhaps diagnostics working group meeting. It's Wednesday, June 1st. Let's start. If you guys are okay with it, everybody should have access to the Google Doc, and just drop your own name in there. Maybe it would make sense to go around and everyone just say their name and a project that you're working on that's relevant to diagnostics. Is that cool?
Sure. Oh, okay, I'm Pat Mueller. I work at NodeSource. I was kind of cat herding some of the meetings earlier. We do diagnostic stuff at NodeSource. That's my interest.
Cool.
I guess I'll go next. My name is Ali, and I work at Google, and I work on Node.
Hi, this is Paul Irish. I work at Google on Chrome DevTools and performance stuff. In the room, we also have some other people here.
Hey, I'm Pavel Feldman. I'm TL in DevTools.
Hey, Pavel.
I'm Fadi. I'm working on the Chrome tracing in general.
I'm Andre. I work on timeline and tracing in Chrome.
How is the volume for the folks in the room? Can you guys hear okay?
Yeah, I can.
Yeah, not bad.
Great, awesome, thanks.
Okay, I guess I'll jump in. I'm Michael Dawson. I'm with IBM. Been participating a bit with Richard and some other team members in the postmortem work group. And tracing and so forth relates to that, as well as a bunch of the other discussions going on today. So that's why I'm here and interested in participating.
Hi, my name is Andreas Madsen. I'm with No One. I mostly work on async wrap to provide good stack traces for async I/O.
Awesome. I'm Jason Laster. I'm at Mozilla working on Firefox DevTools, and we're working on a new debugger front end, which hopefully can debug Node as well.
I'm Matthew Loring. I'm here at Google as well. I work with Ali on Node and on tracing and debugging for Node.
I think that leaves Fadi and Miles and me.
I'll go quickly. I'm Miles. I work for IBM. A lot of focus on LTS. Really interested in debugging as a platform and just seeing where that goes as far as a working group and getting different vendors involved.
Fadi, you want to just introduce yourself? You're on mute.
Yeah, I'm in the same room. I'm just logged in so that I can present in a second. Sorry about the confusion.
Oh, okay, no problem. So I'm Josh. I am with the developer division at Microsoft, representing Microsoft with the Node open source project. But I work with the Chakra team, the Visual Studio team, Windows team, a number of different teams. So let's go ahead and jump into the agenda. So before all the Chrome debugging protocol stuff came up, we were going to talk about trace event, and that I asked Ali to give us an update. I wanted to discuss a little bit about my trace module, which I've been working on. Then we'll talk about the Chrome debugging protocol, async wrap, get an update. Trevor's not here. Maybe Andreas can talk to us. And then we can finish by talking about the diagnostics working group and how that relates to this group. We can take live notes. Everyone can contribute in the Google Doc. So with that, Ali, do you want to take over?
Sure. In fact, we have all the experts uh, on the call as well, so I'll let them do most of the talking. In fact, I think trace event and Chrome debug protocol, they may have some synergies. It might make sense to cover those two first, and then we can go into your trace module. And I think to start off, I think Fadi and Pavel wanted to take you through an overview of trace event and Chrome debug protocol and how everything fits together. I thought that might be useful to do, so I'll hand it over to them to talk us through that.
So first of all, I'm going to give a very quick introduction about tracing. And the current state of tracing in V8. So tracing is basically a way so that you can specify trace events. Trace events are events that have begin and end times. You specify them usually in the native code and the C++ code, and there is other ways where we can actually specify them through JavaScript as well that Pavel will talk about in a second. Traces are collected using something called tracing controller. The tracing controller is basically a buffer and a set of configurations. So you say, okay, I want to collect the events in a subset of categories, and then you say start, that will collect these events and put them in a buffer, and then when you press stop, these events gets dumped. The way we use trace events in general are we don't stream them, we just get the dump at the end in general. I know that Node has a use case where this might not be the case, but this is a current state. We believe the platform can be extended for streaming, and we would want to hear more about the use cases that you guys have and see how we can work with that. So what I'm showing you now, I'm not sure if everybody can see this. Okay. Can everybody click on my name and see my screen? And if you do that, you will see that this is an example of a trace for the verge, and this is the level of details we get into when we profile a website using trace events. Basically, we capture the renderer in Chrome message loop at the top here, and then inside of it we have we can jump, for example, all the way to a v8.call function, and then inside the call function we happen to have a major GC here that happens. For each event we get a set of information that is associated with this event. We get, for example, that it was enabled because we were collecting the V8 category. We categorize it as a garbage collection category. We provide two informations about it, the hold duration and the CPU duration. And one of the strong things that we proud ourselves of with tracing is that we also capture the CPU duration of the events, because they give a much more meaningful time of what's going on. Since this is a GC event specifically, we also have the heap size before, some more information and a context about what happened. We can also have something called overlapping samples. So we also collect the runtime samples that show up in DevTools, and we'll show you in a second, and then we can show them here. So when we click on them, actually you can see that there is no meaningful samples here because this was basically a GC, so nothing actually got executed. But if we click and actually execute, and we click here, then apparently this is like obfuscated code, but we know that we have here a top-down tree, and then we can associate this specific top-down tree with this v8 execute event that I originally selected when I displayed this tree, as you can see here. What I'm showing you guys here is a Chrome tracing interface. It's intended mostly for the platform developers, for like Chrome developers, Node developers, V8 developers, and not the actual user base that will be using Node from the front end. From the front end, we prefer that we always use the dev tools, and Pavel can talk about the dev tools. Yeah.
Sure, I'll do it.
Or Irish.
So yeah, just briefly. So I'm just going to show kind of like the same thing up in DevTools. So we'll record a similar kind of a capture. So what is coming in here at this point is loading timeline. It is the same thing. It's a trace. The delta between kind of the data that powers this view and trace viewer versus what comes into here is pretty much a change in the categories here that are being recorded. And so generally this here in trace viewer you record a lot more, whereas what comes into timeline is a smaller subset, kind of just the top level summaries. But at an event perspective, the same data is shared. So we can still go in this case, and let's see if I can. So here we're seeing a minor GC, and we're getting the idea of how much is collected in that GC using the same kind of data that was attached before. Similarly, like if I wanted to look at kind of this area of the trace, I can have a bottom-up view of everything. In this case, both kind of the function, JavaScript function level, in addition to, in this case, kind of like the browser native operations, recalculate style, etc. But in Node's case, you can imagine that we would have the JavaScript functions in the userland JavaScript, in addition to the native data, native trace data coming from Node. And so, yeah, I guess that's kind of the quick summary. Just so we have an idea on kind of what this looks like. See if I can open that up real quick. Let's see. Sure. Yeah. So this is kind of what the trace looks like in both cases. A big JSON blob of individual trace events tagged with their category, in this case, top level, their name, and then any arguments and extra data kind of attached to the trace event. And so this is kind of the standard base layer of the trace serialization that powers both UI views.
Last thing, the next thing we want to talk about is the state of tracing inside of V8. So currently, we landed the tracing interface, which is a big set of macros that can be used by the native code to indicate when a trace starts and trace ends. And it's currently being widely used in V8, not as much as we want, but it's starting to get used more often. And since Node is implementing V8, it's by default can start using these libraries as well, and then any trace that we collect will also contain the same trace events from the Node code as well, and then will show up here, like you guys are seeing here. On the other side, we also have a slightly different project, which is not completely different. It's very similar. So as you can see here, this is actually based on sampling. This is the sampling information that we're collecting. And the sampling information currently are not part of the trace file that we're getting, but we're working on actually making it as part of the trace file. And we're sampling at intervals that you can define. So if Node wants to sample at a lower interval or higher intervals, they can do that. One thing we considered as one of the use cases for Node is that you only want to sample when you're actually serving a web page, or when you're serving one of every 100 web pages, for example. And this can be easily added by deciding when to turn on or off the sampling exactly. You want to add something?
Yeah, we can switch to the remote debugging to the APIs of this, and I can take over.
Sure.
I don't need to show much. Is Paul speaking about how this ties into remote debugging? So we now have V8 Inspector as a standalone project that is on its way to V8, and in the V8 we'd like to have sort of a tooling library. Tooling associated with V8 is going to power it all. It's going to power runtime, debugging, and performance features. And the way, similarly to how it works in Chrome, we like the same remote debugging API to control enabling and disabling this tracing and configuring the categories being captured. So that's pretty much the story. We'd like to perceive it as a box product where you have an API that you could automate and instrument the node instance with, and you can consume the traces in by both of these tools. One is targeting internal developers. It operates native method calls levels. As we have seen in the trace, there were things like the names of the trace events that we have seen in the trace viewer. Those were actual names of the methods in Chrome. So that's the level of detail there. And at the same time, and I would imagine that you would be using that for tuning node performance. At some point in time, you would think about the user-facing, the developer-facing, consumer-facing interface for that. And I would imagine that you would turn to something similar to what we have in Timeline, except for instead of exposing the browser related terms such as frames and navigations and loads, you would operate node terms. To reiterate on it, first, trace viewer is for runtime engineers that are tuning performance. It has a lot of data not necessarily actionable from the user standpoint. The other one is consumer facing. And the rule of thumb there is all the information exposed needs to be actionable. So you can see samples, you own the source, you can tweak the source, and you'll get it working. And the API is wired similarly to V8 Inspector. There's a tracing domain that has methods start and stop, and they will notify you with the event containing the buffer with the actual trace payload. That's all I wanted to say.
Yeah, and I guess I was just going to briefly add both the timeline view, the trace viewer UI. These are existing consumers, which are consumers of the trace event format. But we've seen other people build tools on top of this format, walking through the data and pulling out interesting things. So I think there's also plenty of opportunity for that of just more automated data processing of those traces.
So currently, the way we want to instrument JavaScript code, so you can always do the sampling, get the profile, and get the sample data. And if you actually have more meaningful information or you want to instrument your code, so what we currently do in Chrome is that we use console.time and timeend. So when you use console.time and timeend, they show up in the tracing format as normal trace events, so that you can associate them with everything else going around them.
I can give you an update on what's happening on tracing, like a brief update of what we are up to currently. I mentioned that we want samples to be a part of trace. Well, in fact, we have them as a part of trace for about a year, but we are not satisfied with the footprint that we are getting, and we're consuming a lot of memory, hitting a lot of limitations there. So we are iterating on that to make sure that we get best of both worlds, and we get lean, nice sampling data as a part of trace. So that's one of the things that is currently happening. The other thing that is currently happening is that we are looking at the trace format, and we're looking at ways to optimize it, and there's an active project on bringing it into a binary format driven by Protos for the sake of efficiency. Just for your information.
Yeah, I was when I saw the dump, it looked like a huge file of an array of JSON objects. So I was kind of like, oh god, this is heap snapshot all over again. how big are these files going to be?
We're moving away from them. They actually compress very nicely because strings are highly repeated. So we usually get 256 megabytes that compresses to about 6 or 7 megabytes.
Yeah.
So and we deal with the compressed version in most cases, but we hit the limits a lot when we're doing when we're processing the JSON basically. Otherwise, it just you don't see it that often just when you visualize it or something.
So Fadi, the trace format, that's controlled by the tracing controller, right?
No, the trace format is a format that we all agree on to generate files into that format so that Chrome tracing and the dev tools can be able to read it, right? So so the tracing controller currently generates that format because this is the one is being consumed by the viewers. But if you decide to write your own format, nothing will stop you. And also the trace viewer, not the dev tools, you can write an importer to import any format into the trace viewer model. So it's kind of an agreement. It's not something set in stone. And then we have this document that is on the screen now that actually defines this format very well. And we're going to keep supporting this format for a while, but we're also working on, as Pavel mentioned, a much more binary, more concise, more efficient format.
So you mentioned it's not streaming the tracing data. So I'm guessing the implication is you start tracing, give it a file name, or you give it a file name and you stop tracing and writes to the file.
Yeah, so basically what we do is that we write everything into a buffer, and then we have the trace writer that basically takes this buffer and writes it down. So that writer can be configured by the client. So Chrome currently takes a name through the UI, and you give it a name and it dumps it. So it takes the buffer, transform it into the trace format that you're seeing on the screen, and then you give it the file name, and then it will put the file name on it. Currently, I have an implementation prototype for V8 that D8 uses, and this one just uses v8_trace.json, similar to the v8.log that they use, just a fixed name predefined. Back to your question, there is an important part there is that we have to predefine the categories that gets recorded and predefine whether we want sampling is enabled or not, and predefine everything. So you have to. So we have also another format that is called the trace config format that basically says what recording mode do you want. Do you want, for example, a cyclic buffer that keeps going, or do you want to record until the buffer is full and stop, and so forth. And also, as Paul mentioned, there's a set of categories, so we also define which categories we want enabled for recording as well. And these are defined in the trace config file that gets read before tracing starts. Once it starts, it keeps tracing with this configuration, and then you stop, you dump it, and then either fix the file name or whatever.
So the tracing data is held in RAM.
Yep.
Until you write it out. So there's going to be limitations on how much tracing data you can actually collect in a particular run, right?
So this is, okay, in this case, Fadi, correct me if I'm wrong, this is controlled by the tracing controller, correct?
Yes.
So this would be, and a tracing controller for Node needs to be written, so it would be up to us on how we want to design it, what kind of a trade-off we want to make, what kind of buffers we want to keep, how much of a memory footprint we want, and how frequently we flush this buffer out to the network or to the disk or whatever sink we've attached to this buffer.
Yes and no, because what we want is that we want to be able to use the wired protocol that Pavel mentioned, and if we start using the wired protocol, then we need to make sure that everything goes through the wired protocol. So dumping the buffer will have to go also through the wired protocol.
I guess we need to, so there are many very interesting moving parts here. The first one that is interesting is to be able to reuse the tracing controller that currently operates JSON and that will operate Proto in the future. So the more we align here, the better. That's one important thing. The other important thing is that the tooling API that we expose and use is consistent across the parties, and we hide and basically encapsulate everything behind the wired one. I can give you an example. We've been, before this meeting, we were just talking through the possible scenarios and how they could be sort of addressed. And I can give you an example of one of them. For example, there's a Node instance running in a wild, and we are interested in collecting performance data on it, and we cannot start tracing upfront with all the categories because it will load it out of memory. So what we do is we sample performance, which means that, for example, we agree to enable gathering the performance snapshot, including the sampling, for each 100th network request that hits this instance. And then we write a script that intercepts this network request, uses wired protocol to start and stop tracing before and after it, and dumps it into a buffer that later is being collected and processed. So it's not really a big deal of whether the API is native or wired. It's just kind of our recommendation to go wired for backwards compatibility and consistency. But it's entirely up to Node how to define strategies of collecting that information, the buffers being used, categories being used, etc., and timing when it's initiated.
Another question on that. So the trace points that are added throughout Chromium and V8, that all shows up here. Is this meant to be usable by userland, like by JavaScript modules, native modules?
Do you want to cover?
Can you repeat the question?
Yeah, I can start covering. So Trace Event API, the native one, will work for everything, including Node, V8, and modules. So native information you feed there, and it works. As far as modules are concerned, as Fadi mentioned, what our strategy towards analyzing JS performance is sampling, because sampling covers everything. It doesn't require additional instrumentation, and you get it with a very high precision. We found sampling to be very impactful and actionable. And it doesn't matter whether it's a user code or a module code or any JavaScript code, any JavaScript samples will get there. If you want to add structural JS profiling, where you want to maintain higher level structure events, we currently have a way of doing it through the console API. So you say console time, and I started processing something, then you say console time end, you stop processing something, you will get a nice bar in the tracing, in the timeline for it, and you'll get the entire hierarchy of samples under it. So you kind of mark up your source code you augment it with the semantics of your app.
So I got another comment on that. We currently have pretty high expectations on the trace format consistency, basically the matching of opening and closing events, and this is ensured most of the time by macros on the in the C++ code. And in case this gets exposed to models in a manner that allows like generating opening events without matching closing events, some may break on the client side. So we have a special case when this is supported, which is asynchronous events, and we treat say the user provided console events as asynchronous events, but for the majority of events that we expect to be synchronous, this like the contract is that the caller should ensure the consistency of begin end events.
I didn't completely understand. So synchronous, you're saying most traces that come from a module would be synchronous traces, but is there, in what way would a module author?
I think what I meant is that by default you should maintain a contract of balancing the start and end events for instrumentation. But if you cannot enforce it, and for example, if you're dealing with a synchronous JavaScript code where you still want to augment the samples with the logic of the app, there is the notion of a synchronous event. Does not require the balancing, and the visualizing tools are doing a best effort at aligning things and then lining them up on the same timeline.
Okay. And how would you like right now, is there any way to do that, to add in that's, I guess, what you're calling structural traces into the into modules?
Well, if imagine that the console object that we have in Chrome was a part of Node, and it exposed the time and time map bindings as it currently does in Node. And by the way, there's nothing preventing us from wiring those calls to V8 inspector. In this case, those bars that correspond to user land events will show up as a part of a trace.
Yeah, so console time and time end is just a way of identifying, of marking up a time span. This is implemented in Node's existing console object. In Chrome's console object, which at this point there is a difference. In addition to like exporting how long that time took to the console, it also creates a trace event. And so that is currently a good mechanism for allowing JavaScript to inject trace events into the recording. Performance.mark and measure also work client side, and would be if any kind of mechanism that the native Node code can generate trace events for might make sense, but you'd want something that is kind of core to the platform language.
Gotcha. So you're saying like we probably would need to implement something within Node to take advantage of the infrastructure that you have put in.
Yeah.
Yeah, and that is related to the console object integration. We have with the V8 inspector, you get the command line API and console object treatment, proper console object treatment. It is not yet integrated with Node because we would need to wire it with a terminal, and we would need to wire it in a way that is sort of backwards compatible, so that all the terminal output that Node is generating was consistent with what it did. But as a part of this effort, once we let V8's console object to be Node's console object, you are pretty much getting this for free.
Do we have right now any sort of console.trace or anything like that? Anyone know in Node? Do we have anything that does anything like this?
I think for the sake of being unblocked and experimenting with it, it wouldn't be too hard to expose it just like that, and then see how it feels. I mean, we shouldn't be blocked by the console integration to get a feeling of how traces with the user land structural profiles would look like.
And what would those, like, so when you, let's say we use that, whatever implementation, and what are the trace events just generic at that point? They just record the stack, let's say, and a timestamp, and...
Could you share this? Fatican, could you go search for console base, or what is it?
No, let's give you this.
Yeah. Could you open this link? We'll just show it to you on the link. Here. Yeah, this guy.
Josh, are you looking for stack trace information or generic tracing events?
Actually, where I'm kind of going with all this, so I'll kind of, maybe I should just describe what I've been looking at myself.
Wait a bit, maybe I got what you were asking properly. So those are the, Fatih is sharing the screen as the thread debugger code, and those are the bindings that are wired to console time and time end methods.
Mm-hmm. Gotcha. Yeah, makes
sense. And that's what they do. They say trace event, native trace event, async begin and end, and that is it. So you place those two.
And I have an example as well. This is how it shows up in the trace. Yeah. So I was able to do like here, if you see console.time and then time end, and then I was able to record the quick trace, and here it shows up as a normal trace event with the category blink.console.
Yeah. Yeah. I wanted to finish the point. The point was that you get the bindings for console that you have today, you add those two methods, or you add those two lines in those two methods, and provided the trace event infrastructure is in place, that's it.
Okay, yeah, that makes sense. That was exactly what I thought. So you're basically wrapping some of the trace event macros. So just quickly, because we're getting out of time and we need to move on, but let me just quickly describe what I was looking at and maybe we can just see how it fits together. So basically, I've been investigating. Right now, there's no unified trace system really in Node that could be used by the Node core components, by native modules, by ecosystem modules. Console.log maybe a little bit, but there's not really an easy way to hook into it. So I've been looking at just a basic pub sub setup that would allow JavaScript or native or core components to emit traces, just to publish a trace by calling something on the broker, and then the broker would publish them out to register JavaScript functions or native function pointers. And really, what I was going to bring up in this call, but we don't have a ton of time, I'm going to have to just discuss it on GitHub, but I wanted to find out how we can make everything go into some unified system, and that's what I was kind of wondering about trace event. Is it just going to be something that's for the platform and for the core, or can we use that for everything? And it sounds like you guys are saying let's use the tracing controller, which would that's kind of equivalent to, in my side, what I call the broker. But I think you guys would say use the tracing controller and then wrap the trace event stuff in things that are exposed to JavaScript.
So just to be clear, tracing controller is the place where it actually collects the buffers, dump the traces, and so forth. What we have is actually what you want is create a wrapper on top of like a JavaScript call into a C++ call, and then transform that in a trace event. And this can happen anywhere and applies to any tracing controller. It doesn't have to apply to a specific one. Like the example we showed you in Chrome, it actually is being used by the Chrome tracing controller and other tracing controllers that we have there as well that pulls in these events. So
yeah, but on a broader topic, the tracing buffer, the tracing controller operates the tracing buffer, and all the performance information. Our vision for Chrome is that all the performance information, be it internal or be it a user land, ends up in the same buffer. You have control over what you're collecting, but there's a single buffer, and this buffer is extremely efficient. We're looking at a zero overhead. We are not doing anything streaming because we're only concerned about filling up this buffer without doing any extra work at all. And you mentioned the callbacks and JavaScript callbacks, and these all would raise concerns as far as overhead and side effects are concerned. So we don't like skewing profiles at all. So this is a zero overhead buffer. You grow it, everything goes there. And then we sort of discussed the means of delivering this buffer to the viewing systems, and it could be a remote debugging protocol or some serialization, persistence. And we also discussed the means of populating this buffer, and today this is native trace events or their JS wrappers.
Okay, I think that makes sense. Can we look? Your implementation is all within V8 now, or?
So currently, the implementation we have so far landed the trace event macros, and it's currently sending all of the trace events to the Chrome tracing controller. There is a project within Google working with Ali and Matt on actually getting the V8 tracing controller landed, and we're aiming for a generic tracing controller that can actually be used by D8 as well as Node. And we're planning for some infrastructure that can be expanded or extended by any embedder of V8 to start collecting traces. Because currently, Chrome, which is one of the clients of V8, has its own tracing controller, and we're directing everything to it directly now. And it's also being used by the DevTools as well. But for V8, we're working also with the DevTools team to actually create a unified interface that people can start gathering traces from outside of Chrome. And this is the point where we are at now. The API is there. If you want to implement your own tracing controller from scratch, you can do it now on top of V8 because the API is 100% there.
Right. Just right now, it would send it to nowhere unless you wrote your own implementation.
Yes.
Okay. So I guess, yeah, I guess we'll. Okay. I want to. It seems like your thing is the foundation, can be the foundation for all trace in Node.
Yes.
If we needed to stream out the buffer somehow, then we'll figure that out. But like we can figure out those concerns later. That central implementation would make sense to use.
Yeah, the central implementation is intended mostly to read the configuration, allow you to start and stop, and provide a simple buffer implementation that you can override and have your own.
You mentioned it's very efficient. What kind of overhead does it add to turn the trace on?
So the trick is that we've tried to keep the overhead if you are an off category. That means that you're not collecting this category, which is what the user will be facing most of the time, is to be as minimal as possible. So actually we try to push it to one branch on a static variable, and this is the overhead of a missed, like a category that you would not record. If you are going to record, most of our overhead is based on getting the time, because we get the high resolution time for the wall clock and the CPU clock, and both of them are very expensive, and this is where most of the costs are. So off overhead is almost zero. On overhead, we're currently at 4 microseconds.
And do you know, does that, like, that's 4 microseconds per call? Do you have a, like, if you turn
per
on...
trace event call, yes, because this is the overhead of measuring the high resolution time as well as the CPU time, as well as putting into the buffer. We pre-allocate the buffers to save some overhead there, so we don't do a memory allocation every single time.
Right. So do you have a feel if you turn on that tracing in Chrome, does that slow you down by 5%, 10%, or?
We are talking between 3 to 10% overhead if all of the categories are enabled. But the trick is that you enable a very small subset of categories that gives you the information that you're looking for without affecting the overhead. And then we control using the categories when to exactly trace more versus trace less.
So depending on the set of categories that you enable, you will go from no overhead to some overhead, but you have control over what you're going for.
Okay, understood. Just trying to get a feel for the scope.
Depending on the frequency of the events that you're tracing. So if you are tracing, for example, IC misses in V8, you're going to have overhead. If you are tracing when you are actually doing V8 execute, which is a very high-level event, then you actually get 0 overhead.
For the sampling, the stats are a bit different depending on the resolution of the sampling, and we support 1,000 samples per second and 10,000 samples per second resolutions. You get from 10% of execution overhead on the desktop devices to up to 50% on ARM and mobile devices when high resolution sampling is enabled.
Hey, I hate to be a party pooper, but we have 10 minutes left in the meeting.
Yeah, actually, I was going to say, like, can we? I was hoping we could talk a little bit more about the Chrome debugging protocol. I know we've brought up the tracing functionality that it adds, but could you guys talk more about like why this is good and why we should be using it?
Well, I actually have at least one question. Maybe I can ask that first to help target. So at first I wasn't quite sure why something was replacing the existing V8 debug protocol, which has been documented on a single wiki page since it's been around, I guess. Not documented well. And I know the Chrome DevTools protocol is very well documented, described very strictly and whatnot. So that in itself is good, but I guess my understanding is the current V8 debug agent that's a node is just no longer supported. And that Fedor maybe had worked to get it back working after it kind of came out of V8 directly. And so that this Chrome DevTools is really kind of the replacement for that protocol. Is that understanding correct?
Pretty much. So the history on the topic is that we started working on Chrome DevTools on WebKit Web Inspector, obviously in 2009, and we quickly ran out of V8's protocol capacity and efficiency. It didn't operate object mirrors in an efficient manner. For example, you couldn't get properties of an object without getting the values of those properties, and many things alike. And it was also based on the mirror objects in V8 that were adding quite a bit of the overhead. Now, at some point in time, the maintenance of the old protocol became so bad that V8 decided to basically drop it and put it into the non-maintainable mode, where the remote debugging protocol was replacing it de facto in Chrome. Fast forward to today, the agreement between DevTools and V8 teams is that the V8 Inspector API becomes the debugging API for V8. This allows V8 team to drop the mirrors and drop support for the Chrome debugging, for V8 debugging protocol altogether. It's not that they were doing much about it, but they maintained this infrastructure of mirror objects that was simply an overhead and was sitting in their source space. So for them, this means that we are going towards something more maintainable. For us, it means that we are aligning on a protocol that operates in a more standard way, that operates in a more efficient way. So there's really nothing bad about this switch. It's only getting rid of the old chunks of code.
So we probably can also start, if we're thinking about this being the new debug interface for Node, which I assume we are, then presumably we'll pull out the old one at some point. So, you know, part of the story should be how we deprecate that and when that comes out and stuff like that.
Well, I mean, I'm in agreement, and I think most of us are in agreement. We like the Chrome debugging protocol. It has, like, I could defend some parts of it. It's got all of the domains and things that go beyond V8. That's kind of what, like to justify us in Node switching over. I mean, I think we want to, but I was hoping that would be the conversation here. Like, let's just all be on the same page with that. I mean, is there anyone here that has concerns about the new protocol, or would say, oh, well, there's something better about the old one, outside of Google?
Yeah, I mean, I think, to me, having both Microsoft and Firefox folks here is awesome, because, I mean, I'm sensing that the thinking is that they would implement the same debugging interface. So they wouldn't probably reuse any of the code, or, you know, maybe look at it for design tips or something, but in theory would implement the exact same API for their version of Node on their JavaScript engine. And if it seems like that's doable, then I think everybody would be pretty happy with that, to have really kind of an official Node debug story that would work cross implementation. So, but, you know, I don't work at Microsoft or Mozilla, so I'm not the person that's you know, can say that that's doable or not. But that's I think it's great to hear the basically positive reactions. I think we do. Josh, did you have an issue up? And I know you had like a couple of issues, like what's the governance of the API, and, you know, how long is a particular version of the API supported by, I guess, Chrome, and who's going to support this code? And there were a handful of questions like that, which I thought were really a pretty good set of questions to be asking.
Yeah, Paul and Google, what do you guys think? Are you happy for everyone else to be implementing the protocol too, like the other engines and the other tools?
Well, of course, yes. I think to address the support and maintenance concerns, I think we have a very good track record history-wise. We've only been adding to the protocol. We haven't been breaking backwards compatibility. Everything is developed in the open. The protocol is documented. Our front end, which is the reference implementation for the client of this protocol for us, because we are a DevTools team, it is open source. We have it open in the Chromium repository, as well as we have a GitHub mirror. The source code there is modular, and one of the modules that it contains is called SDK. And I, for example, know that Paul was able to reuse that SDK for his own CLI tool that he was building for quite some time. And it was pretty much a out-of-the-box solution. You take the headless SDK, it wires over the remote debugging protocol. It introduces higher-level abstractions for scripts, requests. Those are all, of course, browser terms, but scripts and breakpoints are not. And you could right away you could hack from there. So it's hackability of the protocol. It's JSON nature. It's open as it's very good, and we've seen a great adoption there. So we don't see why everybody else wouldn't try and do something there. The other interesting property of the protocol is domains. You've seen the 30 Chrome domains, but you can have 10 Node domains, and you could have your own UIs. Depending on the front end of choice that you pick, to extend those and expose those domains there, which is pretty exciting.
So that's a pretty interesting point. So we could create our own domains?
Of course, absolutely. That's the whole point. Chrome has its own specific domains. Why Node wouldn't have those?
And how would we? Is that just we write our own protocol of JSON or something? And
so the way we deal with it in Chrome, and I'm currently splitting. We have a bunch of properties that are using remote debugging protocol infrastructure. What I'm currently doing is I'm splitting the V8's domains from the Chrome's domains and seeding them in different places so that we could move the thing into V8. And the way it works is you get this JSON description of your domains. We have utilities that generate strong type APIs and wire dispatchers for those domains. And then you implement the handlers for V8 in V8 and the handlers for Node and Node. And then you've got the Uber dispatcher that basically pumps all the messages and just figures out into which dispatcher to send that wired message. And currently for Chrome, it processes most of the things in Chrome, some of the messages in Blink, and eventually they go in V8. And you could imagine that in Node, a similar thing would happen. The message would hit Node. It will figure out what it is and either dispatch it on its own or send it further. As long as the main contract of JSON RPC is maintained and things are isolated using domains, everything works. We can talk about reusing the utilities that we use that we employ for generating those dispatchers. For example, if you've looked at V8 Inspector, it was pulling. It consists of two parts: V8 Inspector, the debugger itself, and the Inspector protocol, which is the harness for generating the handlers and wired dispatchers, and a couple of build-time dependencies for Jinja that are actually used for the code gen. So you could reuse those Inspector protocol and Jinja parts. They are V8 debugger agnostic. You could reuse those to create your own domains and add them into Node.
And so if Node wanted to say, look, these are the 10 domains we support, and here's the couple we've added to Node, we could have that JSON file in Node, which represents, that's the canonical thing that Node supports.
Exactly.
Well, it's late, and it's almost 1 o'clock, and we got to jump on the CTC call. Does anyone else want to have any questions on CDP?
I guess I didn't realize the build time flag is no longer there. It's in by default now. So it's in. I think when I saw it, you still required the with inspect, and somebody just told me on Slack at work. They said, "Oh no, it doesn't. It's built in," and I'm like, "No.
Yeah.
I just looked. I saw it's
Do you guys not take off on Memorial Day?
Happen somewhere.
I think that was one of the CDC recommendations to drop it actually, and that's what Ellie did. But unless you specify the command line flag, it's a no-op. So it's a build time.
Okay, well, there's more to talk about, I guess, but we got to wrap this up. So, I just want to bring up at least when we'll have the next meeting, which I was going to shoot for the first Wednesday of each month. So, and we can, if we need something else in between, we'll figure it out. Otherwise, let's chat on GitHub. I know we got to talk about expanding into a diagnostics working group. I guess let's go back to GitHub for that for now. If we need to schedule a short meeting, Pat or anyone else next week, then or another time we can. But yeah, I think we should continue these discussions, and maybe we can start a couple different threads in the tracing WG repo for now, and we can go from there. Cool. Well, thanks a lot, everyone, and see some of you soon. And yeah, have a good one.
Thanks.
Bye.